Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
I
love that word.
Hello and welcome to Diffusion. Sit back and relax while we capitalise your brain with weird and wonderful science. I'm Ian Woolf. On this edition, writer Bijal Trivedi talks about cystic fibrosis and the path to a cure. But first, here's news of neo-Nazi face recognition. Criminal, fascist and racist. The Clearview AI face recognition software used by police departments all over the USA and Australia was founded by computer criminals and funded by extreme right-wing white supremacists who openly talk about ending democracy. Like most face recognition software, it wrongly identifies as criminals people who aren't white or male. Clearview AI is the company that scraped over 3 billion photos from social media and websites without consent, violating the copyright and privacy of billions of people around the world. Clearview's image database is almost 7 times the size of the FBI's and growing because it's stealing photos every day, not only from online but also from police databases. Its mobile app can match faces and give you names with a tap of a touchscreen, also showing you photos you've never seen. Clearview AI force every user of their software to upload a copy of the photo they want to match into the Clearview image database permanently. This includes police investigating child abuse victims in Australia, according to the founder, Kamhon Tonthat. This is highly illegal. Staff at Clearview AI spy on the police use of the database, as evidenced by the company calling police about talking to a journalist immediately after police tested a photo of a journalist. Luke O'Brien at the Huffington Post has written a deep dive article of the white nationalist hate group connections of who founded Clearview AI, who's worked there, and who funded Clearview AI. Do we want these people influencing police departments? Phishing is a crime that tricks people into revealing private information that can then be sold on the black market for identity fraud, or cross-check to validate, update and grow existing databases of stolen private information. People buy usernames and passwords to commit identity fraud. Kamhon Tonthat first became famous in San Francisco in 2009 for unleashing a computer worm that phished the login credentials of Google Mail users. His victims received messages on Google Talk, Google's instant messaging client, directing them to click on a link that led to his website, which asked visitors to log into their Google Talk accounts, giving away their usernames and passwords. His site used this information to send replicas of the original message to the user's contact lists, replicating the worm. Tonthat showed no remorse after journalists traced the worm to him. He simply set up an identical phishing site somewhere else. Kamhon Tonthat got funding from billionaire Peter Thiel, who owns surveillance and data mining company Palantir, which works with the US Immigration Department. Tonthat also got funding from Thiel's protege, Charles Johnson, who stated on Facebook that he is building algorithms to ID all the illegal immigrants for the deportation squads. Many of Peter Thiel's friends and followers belong to white nationalist hate groups that want to overthrow the US government. Luke O'Brien links to all the evidence for this in his article. Clearview has contracts with the US Immigrations and Customs Enforcement, the US Attorney's Office for the Southern District of New York, FBI agents, and members of Customs and Border Protection. Hundreds of police officers at departments around the US and Australia, including the Australian Federal Police, are among its users. Clearview AI is being sued. In Illinois, there's a class action based on violation of the state's Biometric Information Privacy Act and the Consumer Fraud and Deceptive Business Practices Act. Google, Venmo, Twitter and Facebook have sent cease and desist letters. Clearview may also be charged with breaking the US Computer Fraud and Abuse Act, common law trespass to chattels by using people's computers for things they didn't consent, breach of contract for breaking social media terms and conditions, and of course, copyright infringement for profiting from photos without the consent of the photographer. Putting your photos online doesn't take away your copyright. For Clearview AI to fulfill its agenda, it needs images from surveillance cameras that aren't available on the open internet. Clearview AI offer free trials to police as well as selling subscriptions. The company tricked police into uploading surveillance images. The essence of the scam is as viral as an old-school chain letter. In order to access the stolen data, you have to add to the database. You can't use Clearview AI face recognition services without uploading your photos to the Clearview AI database. Just to be clear, face recognition can work without the photos from the user from being added permanently to the database of the face recognition company. Clearview AI is a self-perpetuating phishing scam. Luke O'Brien's article is titled "The Far Right Helped Create the World's Most Powerful Facial Recognition Technology" and is published in the Huffington Post. The Clearview AI face recognition app is definitely a tool of police that needs to be defunded. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. Breath from Salt? Bijal Trivedi is the science and technology editor at The Conversation in the US. She's written a book called Cystic Fibrosis, a Deadly Genetic Disease, a new era in science and the patients and families who changed medicine forever. Last week, we started talking about Paul Quinton's research into the connection between extra salty sweat experienced by people with cystic fibrosis and the mechanism of the illness. I continued the conversation by asking Bijal if Paul Quinton had to pioneer the techniques of examining the sweat glands he harvested from his own skin.
Yeah, I mean, it's an amazing, amazing process because a sweat gland is microscopic, first of all. So you basically have to separate it from the surrounding cells. And it's about the third of the diameter of a strand of hair. So that's how small and finicky this thing is. And it's slippery. And he had to develop a system of dyeing these sweat glands so that he could actually see them under the microscope, because otherwise they would be transparent. He had to develop these weird little pipettes, glass pipettes that had very, very fine ends so he could manipulate the sweat gland under the microscope. I mean, the whole process before he was able to make the measurements that told him that the salt regulation was messed up, it took him 8 years to develop the technology to be able to do that. So it was not quick.
That's astonishing that you could work for 8 years harvesting the sweat glands from your own skin while continuing your career. It just sounds like a lot of work to persuade people that you're on the right track.
Yeah. Yeah. Originally, when he wanted sweat glands from someone with the disease, he took his own. But when he was looking for normal sweat glands, because, he had to compare them, the function of the normal sweat gland compared to his own, he actually got the skin samples from dermatologists. So when people get hair transplants, they take cores from the lower part of the scalp, which never seems to go bald, and they take that skin and implant it into sort of the bald pate of the head. And so from the bald region, that was skin that dermatologists would originally just throw in the trash. And he basically asked them if he could have that skin to get normal sweat glands. Yeah, I mean, he was very improvising, and he's a real character.
And so what's the next part of this story? You mentioned personalized medicine.
Yes. So CF, or cystic fibrosis, was a trailblazing disease. It was one of the first disease genes to be discovered in 1989. It was one of the first diseases where they tried gene therapy, which is basically the idea that you have a broken gene that is deformed and doesn't work. So let's put in a healthy copy of that gene. So those experiments with cystic fibrosis were done throughout the 90s. And unfortunately, though they had proof of concept that it sort of worked, it was just too difficult to do. So when you put a virus carrying a cystic fibrosis gene into a human airway, the immune system would go nuts and wipe out the virus carrying the gene. So it was another first there. But what has happened with cystic fibrosis is it's really sort of providing a roadmap for other diseases, other genetic diseases. And that's because the way Vertex Pharmaceuticals developed treatments for this disease was mutation by mutation. So there are more than 2,000 mutations in the cystic fibrosis gene, and you can divide them up into groups. So in one group, the channel that allows salt to go in and out of the cell, it doesn't work so well. And in my book, Breath from Salt, I've called that the doorman problem. So there's some group of mutations where it's like opening a door. The door is stuck. And so the first drug that Vertex developed was for people who had doorman mutations. This door wouldn't open and allow salt to move back and forth. And that was 4% of the patients with this disease. Then they moved to a different set of common mutation and developed a combination drug that would work for that mutation. So what they did was they went mutation by mutation, sort of, it's like getting more and more of the pie. If the pie were the pool of CF patients, slicing off a segment more with each drug. And when President Obama launched his personalized medicine initiative, the disease that he pointed to was cystic fibrosis. And that's because of this mutation sort of specific approach that the drug company took.
And of course, all of that will be able to be applied to other illnesses.
You know, one thing that's just mind-blowing about the mutations that occur in the gene, when it means that a gene makes a protein, that's its goal. So when you have a mutated gene, in many cases, you have a protein that's misfolded. So think of a piece of long spaghetti. It has a shape that it likes to assume. But in these patients, the protein is misfolded. The idea before they started drug development was, okay, if you have a misfolded protein, you can never fix it. There's nothing you can do. But what the Vertex scientists decided to try was find a drug. It was almost like a chaperone. So imagine if you can't put a jacket on properly and somebody comes and helps you, these drugs essentially help the protein fold correctly. And there are lots of diseases, Alzheimer's and Parkinson's among them, where you're struggling with a protein misfolding. So this success with cystic fibrosis, it creates a lot of optimism that maybe these protein misfolding diseases, there might be a way to treat them with a drug. So that's a huge breakthrough. I mean, they essentially created a different category of drug.
And you mentioned an amazing woman researcher earlier.
Dorothy Anderson. Dorothy Anderson was a hardcore scientist. She lost her parents when she was in college, and she finished college, and then she put herself through medical school at Johns Hopkins while also working as a research assistant on the side. And the 1920s and 1930s, that was a time where you didn't have many female physicians. And in fact, patients were actually discouraged from seeing women. Women were really relegated to hygiene practices like good housekeeping, nursing your child, anything related to babies, but nothing else. They were pretty much banned from other fields of medicine. So when Dorothy Anderson was not able to find a job and a residency as a physician, she went back to school and got her degree in pathology, which was something slightly more acceptable for a woman. And so she sat in the bowels of babies' hospital and she did her autopsies. And it was during one of these autopsies of a young girl that she discovered the pancreas was completely deformed. And this child, the physicians thought she died of celiac disease. But when Dorothy Anderson started doing her dissections and her autopsy, she saw that there was a lot of disease in the pancreas and other organs just didn't look right. She started to pull together the evidence. There were scientists in Australia, in England, in Europe, who had all sort of noticed these oddities with these so-called celiac patients, but none of them had pulled all the clues together. And that's what she did in her paper in 1938. And she continued to work on that disease for the rest of her life. But she didn't just study CF. She also, because she was a pathologist, she had a collection of hearts from babies that she had collected, babies who had died very early on. And these hearts had congenital malformations. So when surgeons in the US were starting to think about bypass surgery, it was her collection of hearts that they used to make some of those breakthroughs.
A lot of patient groups don't know how to engage with the researchers and how to move things forward. Do you think there's lessons for people with other illnesses that aren't being resourced, the research isn't really well financed?
I think one of the things that was very impressive, particularly as when the foundation started, it was obviously pre-internet in 1955. And one of the most important things that they did was really connecting all the patients together under a single umbrella. And I think that would be a lot easier today, finding all the patients who have a disease in common so that they can pull together and start building a registry. Because one of the things that makes it hard for pharmaceutical companies to engage in research is clinical trials, because patients may not be known, they may be scattered. And that's also what makes it difficult for researchers to delve into the cause of a disease, because they don't have enough patients to study. So I think when the foundation started its registry, that today remains sort of the gold nugget of the foundation. They have close to, let's say, 90% of patients in the US with CF are seen in the foundation's care centers. So they know all the patients, they know all their medical histories, they know which patients are good for which trials because they know which mutations each person carries. They know their medical history. They know who's had certain complications. So the registry was really critical to everything the foundation did later. It was critical for drug development. It was critical for researchers. And I think if there's one powerful lesson, it's to establish a registry for your disease so that you have something tangible that you can offer a pharmaceutical company or a group of researchers where they don't have to look for people, for volunteers, for study subjects. That was really impressive to me. They started that in the 60s. It continues today, and it's just a gold mine of data.
Totally makes sense, right? You've got the data. You can, if you all get together, I know that in the UK, people suffering from myalgic encephalomyelitis, chronic fatigue syndrome, have started a registry of patients there. And I think they hope to get that data to researchers to help them work on treatments?
Yeah, it's an approach that a lot of nonprofit health organizations in the US are embracing, looking to the CF Foundation as sort of the beacon of hope, the example that everybody wants to emulate. And, the other thing that was a lot of the people at the foundation told me was what was important was there was only one Cystic Fibrosis Foundation. So all the funds went to this single organization so that you weren't duplicating efforts, you weren't splitting resources. And I think there are a lot of diseases, breast cancer and lung cancer are just two that come to mind, where you have multiple organizations. And if you have multiple organizations for the same disease, they're actually competing with each other. They're competing for dollars, they're competing for research grants, and rather than bringing all the science together, you're kind of splitting it, and you don't know what the other foundation is doing, you don't know who they're funding, what approaches they're funding. So I think that was one thing that made this Cystic Fibrosis Foundation so powerful. The 1970s, the Cystic Fibrosis Foundation did a sort of a massive reorganization, and they centralized the foundation so that all the funds were coming into the Cystic Fibrosis Foundation headquarters, and people in those headquarters were deciding which scientists to fund, which strategies to pursue. And I think that's really important, because when you have a disease and multiple organizations trying to find cures for that disease, all those organizations compete with each other. There's a lot of redundancy, there's inefficiency, and basically that delays treatments for the patients. And it also splits up registries. So it was just very, very impressive to me that the Cystic Fibrosis Foundation, they got their act together really early on in the 70s. And from that point on, it was one foundation with one mission, which was originally to find the cause of the disease and then find a treatment. And now the foundation's mission is to actually cure the disease. So what they are envisioning, what they're hoping for, is that they're embarking on a whole new generation of treatments. And what they say at their meeting is they want patients to walk into their doctor's office and say, tell the doctor their problem. And when they leave that physician's office, they can say, we used to have cystic fibrosis. Now, that probably sounds crazy considering it's a genetic disease, but 20 years ago, fixing a broken protein sounded pretty crazy too. So they don't let anything stop them, and they've embarked on so much new science, which is just mind-blowing. So I think that's one thing that really amazes me about this foundation. One of the very unusual parts of this story, and a big part of Breath from Salt, is the venture philanthropy angle of this story. And basically, when the Cystic Fibrosis Foundation began to fundraise for this drug development, they needed to raise hundreds of millions of dollars, which, if you think about the patient population, it's just 30,000 people in the US. And it's a tiny foundation, not much support from government. How on earth were they going to come up with the money to fund drug development? Because drug development on average costs about $1.5 billion per drug, give or take about 500 million. So how did they raise this money? And that was one of the most fascinating parts of this book, was the effort to entice donors to believe that it was possible to make a drug and to donate money without any strings attached. So basically what the foundation did was it secured donations from people who donated tens of millions, all the way down to those who were donating $10 or $15. And they amassed all this money and they invested it in this drug company as seed money. So they funded all the early research. They funded the research up until the point where it was clear that these drugs were having a therapeutic effect, and the point when it was clear that pharmaceutical company could actually make a profit if they completed all the clinical trials. So it's pretty amazing that they were able to do that. And I think that's one thing that really differentiates this effort from all others. And of course, the foundation is well funded now because of some wonderful things that happened. But venture philanthropy was really the key to funding this drug development. So I think that's really yet another element that makes this story very different.
Well, Bijal, thank you very much.
Thank you, Ian. It's been a pleasure talking to you.
That was the final part of my conversation with Bijal Trivedi, writer of Breath from Salt, about cystic fibrosis and how patient advocates raised money to fund research to find a cure. And that's all from us this week on Diffusion. Are you a scientist, artist, biohacker or maker who'd like to be interviewed about your work? Would your company like to sponsor Diffusion? Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please like the Diffusion Science Radio page on Facebook and rate the show on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. The news music was Rhinos Theme by Kevin MacLeod of Incompetech.com. I produce Diffusion, which is broadcast around Australia to 28 stations on the Community Radio Network, including 2RBM in the Blue Mountains of New South Wales, 8CCC in Alice Springs and Tennant Creek, 2MVR in Nambucca Valley, 3MBR in the Mallee Border districts of Victoria and South Australia, City Park Radio 7LTN in Launceston, Tasmania, and 2XXFM in Canberra. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to our podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 1,000 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus on the stories you want to hear. Join my patrons at patreon.com/diffusionradio. Make a donation through paypal.me/IanWolf. Support Diffusion by buying from the affiliate links at diffusionradio.com/support. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.